Thank you for taking time to do this interview with me. Just to reiterate, my name is Annie, and I created Sustainability Beyond the Lab to highlight sustainable innovations of today, as well as the barriers that prevent their scale up. Could you please give a brief introduction of yourself as well as your research, especially at Cornell?
Yeah, sure. I'm Deepa. I recently graduated my master's from Cornell. So I did my master's in materials engineering, and my research was focused on figuring out how to use electrolyzers that convert CO2 into renewable natural gas or other types of value-added products into a dairy farm. So dairy farms currently have, or a lot of large-scale dairy farms have anaerobic digesters. And the idea was that we can add our electrolyzer with the technology we use, which is pulsed electrolysis.
Mhm.
And through that, we can improve the RNG, the renewable natural gas production for that dairy farm to be able to get the farmers more profitability.
Great. For audiences with not much of a technical background, what is kind of the problem that your research seeks to address, and what approaches does it do to address this problem?
Yeah, so with the question about the the problems that this research wants to address, I think that that's more of figuring out how to improve the viability of this technology.
Mhm.
So we use something called pulsed electrolysis, which the idea is that an electrochemical system, which is normally like an electrolyzer that has a liquid electrolyte and then a cathode and an anode,
Mhm.
we're trying to make sure that that sort of system is profitable for CO2 reduction. So many people have used this technique for hydrogen formation, like water splitting is the more common term for it. And then also for like ammonia production as well. But with CO2 reduction, it's a little bit more difficult to improve profitability for it.
Mhm.
So with my research, it was basically figuring out how can we make this profitable in general. But then on the other side of it, with the actual application being dairy farms, it was how can we make sure that this is not just profitable for the company that's working on this electrolyzer and doing this sort of work, but also for the dairy farmer that's going to be having this electrolyzer on their farm and getting this our renewable natural gas that it produces back into the grid.
Yeah.
Yeah.
Are there any projects that you worked on that you find more exciting or particularly unique?
Yeah, so I think I have worked on a couple of projects across the energy sector. I think one that I would find unique is probably when I was working in Texas A&M. So my undergrad was in Texas A&M, and M,
Mhm.
and I was doing electrical engineering. And I decided to go with creating a senior capstone thesis instead of the senior project. And my thesis was about utilizing machine learning into dye-sensitized solar cells.
Mhm.
And it's basically figuring out how to create more efficient dye-sensitized solar cells by looking specifically at the anode material. And the machine learning model was predicting based on the changing of the anode material what the performance was of the overall dye-sensitized solar cell. And I think it was interesting because it was the first time that I got to like see this intersection that I was doing myself. So there was this intersection of like the machine learning side and also the electrochemical side, with also that like power grid and power struct and energy grid and things like that. Because ultimately, what happened was the project, once I created this model, my advisor ended up putting this solar cell performance into another project that she had that was basically about improving the cybersecurity of the power grid.
Mhm.
So, like, there was a lot of components to this that it was cool to just see it kind of all come to life.
Yeah.
And that was a great experience. Yeah.
Yeah.
Yep.
Um, your work on like dye-sensitized solar cells, as you mentioned, and on CO2 electrolyzers for dairy farms, as well as how you consider the profit aspect of that. What do you see as kind of the barriers that prevent these sustainable technologies from scale up? Is it more on the economic side, like profit, or public opinion, infrastructure, or is it kind of a combination of all of these things?
Yeah, I think that's a great question. So there's a couple factors that come into play whenever you're looking at scaling up this this specific technology with CO2 reduction. And I'm not as familiar with like scaling up the solar cells,
Mhm.
but also, to be honest, scaling up solar cells has been something that's pretty straightforward for the
Yeah.
last like 10 or 20 years. But looking at it for a CO2 electrolyzer, one of the biggest issues is actually scale up. Like there's a whole space called scale up engineering that
Mhm.
people are looking and basically figuring out what changes during the scale up process. There's a work that I was using that for our economic analysis that highlighted that when you scale up our electrolyzer, it reduces the efficiency of ethanol by, I think, like 18%. And many people, we were looking specifically at renewable natural gas, but many people also look at converting CO2 into bioethanol.
Mhm.
So that was something that was a pretty important number for us to figure out, like, what are the efficiencies that we're going to end up getting if we add this electrolyzer to a dairy farm. So with scale up engineering being such a big part of that process, I think that's one thing that's important. I think the other side of it is also once you scale up the efficiency that you get, you don't exactly, a lot of CO2 electrolyzers have not even been in industry, in any sort of industry.
Mhm.
So we didn't really have an exact number to base our data off of. So when we're looking at it specifically for a dairy farm, there was a lot of numbers that we were having issues with just figuring out if that was a valid number.
Mhm.
And basically, we ultimately did a top or top-down approach, I believe, where we started off with the RNG that gets produced,
Mhm.
what amount is necessary for the farmer to gain profitability, and then we worked backwards. So, and then that's where like the profits are kind of also
Yeah.
important as well. Like a lot of this sort of work is really dependent on the profitability of the technology.
Yeah.
And
Definitely.
there's different policies. So that was like another aspect of my thesis where I was
Mhm.
exploring different policy incentives. And ultimately, like there's these huge policy incentives that were part of the reason why this electrolyzer would even be profitable. But one thing that was interesting is that just with an anaerobic digester without an electrolyzer, so what the current standard is for maybe a large scale farm, that
Mhm.
was about 40 million, I think, in profitability. But just with adding our electrolyzer, it was only 2 million. So 44, or I think it was, sorry, it was 42 million for the just anaerobic digester, and then adding ours, it was 44 million. So there wasn't really a significant difference in profitability, which is why we actually
Mhm.
said that with my thesis, this stuff isn't profitable.
Oh,
And there could be things in the future that could improve profitability, which would be a lot of policy incentives or the technology advancing or even
yeah.
using a different type of technology. But yeah, there's definitely a couple of factors that play into it. And I think public opinion isn't really something that people that we've noticed was a big issue because
Mhm.
at the end of the day, I think for somebody who's buying the product, they just care about making sure that it's
Yeah.
going to give them money.
Mhm.
Um, so like there's not really we didn't really experience any sort of negative public opinion for the people that we were working with, but that could be also a part of it as well. So
Mhm. When evaluating like specifically the scale up of your CO2 electrolyzer, for example, how did you kind of balance that technological efficiency versus cost and policy?
yeah, so policy was part of the reason that this technology was able to be profitable. In fact, a large
Mhm.
reason. We actually did one of the parts of the economic analysis was if we got rid of the major policies. So the major policies that were pushing this technology to be profitable was the California Air Resource Board's
Mhm.
LCFS credits. So I think that's the low carbon fuel standard credits. And the other one was the EPA's credit that was for, didn't do as much in terms of profitability, but it was interesting because with California's credit, it was pretty much without it, it would be marginal profitability. Like you'd be losing a couple $1 million, but when you get rid of both the EPA and California credits, there's no profitability at all. Like you
Mhm.
are in like deep in the negatives. Like it's not even like you're unsure if you're going to make money. And so those were a lot of things that played a role in the profitability side. Like policy was definitely a huge factor.
Mhm.
And when it came to like the scaling up overall with like the technology,
Yeah.
that also was like there's definitely parts of that that played a huge factor, but that just wasn't something that we were focused on in our research. It was more so we like we said, since we did the top-down approach, we made assumptions about efficiency and we would get there. we actually don't know if we would have reached those efficiencies just with the current work that we did. Maybe in the future we would have a better
Yeah.
understanding of it, but yeah.
Then kind of moving on into the future, like looking ahead 10 to 20 years, what kind of advancements in like CO2 electrolyzers or in policy or in any other field of sustainability are you the most excited for or believe has the most potential?
Yeah, I think to be honest, the carbon capture, utilization, and storage, CCUS, I don't really know about the potential of it in the US. I think that there was a large potential for it with different policy shifts, and with current policy shifts, those have
Mhm.
kind of been slowly going away. But I think that there's also been an opportunity for figuring out how to be more efficient with the power grid. Like, I think something that many people have been talking about is with AI data centers, there's going to be a need for a lot of power for these places. So,
Mhm.
figuring out a way to make that power sustainably, whether it's adding more solar, wind, I mean, even nuclear, people have discussed that.
Yeah.
There's definitely a lot of opportunities there. And I think that's a great place to look. And if you're still looking into like if you're still exploring the carbon capture space, maybe not as much carbon capture, but more of like conversion, I think there's a lot of opportunity there for places like waste management. Like that's
Mhm.
definitely something that, like with dairy farms, like there's still going to be manure and there's still
Yeah.
an opportunity for technology to be used to convert that into fuel. It's just
Mhm.
what technology that is still something that's being explored. And some people have gone out and tried these different technologies like improving. I mean, there's like agrivoltaics, right, where you can just have solar panels on top of plants, and that
Yeah.
apparently affects like it helps the plants, it helps people too. So it's like things like that. And then on the other hand of it, like there's still going to be manure. There's still opportunities for anaerobic digesters. Also, New York just got funding for this project where they're working on waste management for water. So
Mhm.
like basically like whenever people's water, there's waste that comes out of that. Like they use anaerobic digesters actually anyways to process the water. So they're trying to figure out what can they do with that natural gas that's just produced from an anaerobic digester.
Yeah.
So there's a lot of opportunities I think there for
Yeah.
the carbon space.
I definitely agree with that. There's so many different directions that are all kind of developing.
Yeah.
Before we wrap up, is there anything that we didn't get a chance to discuss during the interview on decarbonization or sustainability in general?
Yeah, I mean, I think we briefly touched over it, but it's just like the AI is and data centers, I think, are definitely
Hmm.
a space that's going to affect sustainability.
Yes.
And it's really interesting to see how this conversation is going because there's so many people who have so many different views of AI in the first place.
Yeah.
And so it's like, I guess I'm curious to see like what that'll look like in the next couple years, 5 to 10 years. Like it's something that I've asked. I've gone to like a couple panels and seminars, and it's like, how is the state of AI right now going to affect the power grid? Because
Yeah.
people are saying, and on top of that, actually water as well, like with the water that's required to power or keep a data
Mhm.
center cooled, like there's also those environmental impacts as well. So it's like something that is not super relevant, I guess, to like the power side of it, like power generation, but it's something
Mhm.
that's going to impact the environment and how can we sustainably keep these data centers if they're even necessary. I mean, there's questions that come about that's like, what if for some reason there's no longer a need for a data center, hypothetically? Like, how can we dispose of the parts that are in a data center environmentally friendly, like that sort of things. So,
Yeah.
yeah.
I think your perspective on like the different sides of opinions on data centers is really interesting. And I would love to kind of do more research on that for my website as well.
Yeah.
But thank you for doing this interview with me. I loved hearing about your research and your perspectives. And yeah.
Great. Okay. Yeah. No, thank you so much.